Year 10 and welcome to our first video in the recap series. The first thing that we're going to do is remind ourselves about the structure of an atom. Got our little atom of lithium over here. The structure internally and what can cause an atom to become unstable. Okay? So I always like to use an atom of lithium in my examples. So here we are, our lovely little purple atom of lithium here. And I've drawn it as a sphere here, but we know that atoms aren't really spheres and they have structures inside. And we can use the block from the periodic table about lithium to tell us what exactly is inside this atom. So we can see here that lithium has a mass number, sometimes given the letter A, just because scientists don't like writing mass number the whole time. Lithium has a mass number of 7, and that just tells us that there are 7 subatomic particles in the nucleus. And if we look at the scaled in drawing here, we can see that in this nucleus there are 1, 2, 3, 4, 5, 6, 7 subatomic particles. But we've got some extra information as well, because we also know that lithium has an atomic number, given the shorthand Z, it has an atomic number of 3. And that means of the 7 particles in the nucleus, 3 of them are positively charged protons. And I've coloured those in red on the diagram. So we see our 1, 2, 3, 4, 5, 6 and 7. 7 particles, and of those 7, 1, 2, 3 are positively charged protons. Okay. Now, outside the nucleus, on those electron shells, we also have 1, 2, 3 electrons, as these electrons match to the positively charged protons. They balance them out nicely. Alright, so that's a reminder of the structure of an atom. And this structure is the same for any atom. The only thing that's different is the number of protons, which are in red, and the number of neutrons, which I have left blank, left white, because they are neutral with no charge. So atoms just have different numbers of protons and neutrons in their nucleus, and that gives them their identity. But we'll stay focused on lithium for now. Now, of all these atoms, most of the time these atoms are stable and their nuclei are stable, but sometimes they can become unstable. And let's think about why that is and what that means. So if we just focus on the nucleus of our atom here, we can see that there are 4 neutral things which don't have any charge, they're not particularly interesting, but then we have 3 positively charged things. And we know from our basic knowledge in physics that if we put things together that are positively charged, they've got the same charge, they're going to want to repel away from each other. So these protons here, what they actually want to do is they want to push away from each other. They want to get away. They are going to repel each other. And that could mean that this atom becomes very unstable because all of these protons want to push away from each other. But that's really problematic because that would mean that all atoms are always in this state where their protons are pushing away from each other, which would mean their nuclei could never exist, and then we wouldn't have any atoms and we wouldn't have a universe. So obviously something else is at play. And the other thing that's at play is something called the strong nuclear force. And the strong nuclear force is brilliant because what it does is it counteracts the repulsion force that those protons exert on each other, and it holds, and I'm using little black arrows here to show the strong nuclear force that's holding together all of the things that are inside a nucleus. So we have the strong nuclear force to thank for holding nuclei together when, if the repulsion force was winning, all these nuclei would just collapse. They'd all break away from each other and they'd just become floating protons and neutrons, and that's no good. So it is the strong nuclear force represented by these little arrows that is actually holding that nucleus all together nice and tight and staying as one. So thumbs up, we like you, strong nuclear force. However, sometimes in some atoms and on some occasions, the strong nuclear force isn't quite strong enough, and the repulsion effect that the protons want to do to each other becomes too great, or it becomes the greater force, bigger than the strong nuclear force existing within the nucleus. And if that happens, you have got yourself an unstable nucleus. And that is not great. Thumbs down, bad. That's not great, because that means your nucleus is unstable, and atoms don't like to be like that. So in order to become stable again, what our nucleus would do is it's going to emit something. It's going to kick something out in order to become stable again. And that's what we're going to look at in the next video, how atoms become stable again if their nucleus is unstable.